Okay, 3.1, we are learning the chain rule. The chain rule is how you take the derivative of composite functions. Composite functions are of the form f of g of x. To start off, we're just going to decompose these functions. So I'm doing the sine of x squared. So the outer function is the sine. The inner function is the x squared, which means, in this case, f of x is the sine of x. And then the inner function g of x is x squared. And then if I did f of g of x, I'm doing the sine of x squared, and it turns it into this. So f is the outer function, g is the inner function. So if I am doing the square root of ln x, the outer function is the square root. And then the thing I am square rooting is the ln x. Okay, one more. It's the quantity x cubed plus 7 raised to the fourth. So I'm taking the whole quantity and I'm raising it to the fourth. So the outer function is the raising it to the fourth. It is, we call it x to the fourth, but it's whatever it is, I'm raising to the fourth. The thing I am raising to the fourth is the x cubed plus 7, so that's the inner function. So I'm doing f of g of x. I'm doing the g of x and I'm raising it to the fourth. Okay, so this is the chain rule. The chain rule is for the differentiation or taking the derivative of composite functions. So if I take the derivative of f of g of x, I do f prime of g of x. So I take the derivative of the outer function and I keep the inner function the same, and then I multiply it by the derivative of the inner function. Okay, so let's try this first one. So a, g of x equals the quantity x squared minus 5 to the fourth. And I could also multiply this out, but I don't want to multiply this out 4 times. Okay, so if I look at this, this is very similar to this one. The inner function is the x squared minus 5. And I'm raising the whole thing to the fourth power. Okay, so I'm going to do the outer function first. The outer function is I'm raising this to the fourth power. So I'm going to bring down the 4. I'm going to keep the parentheses the same, and then I'm going to now lower it to the third power. Okay, but because the part in the parentheses has a derivative, I'm going to do the chain rule. I'm going to multiply it by the derivative of the inner function, which is the g prime of x. So the derivative of x squared minus 5 is 2x. That's the chain rule. Okay, I'm going to just simplify it a little bit and then leave it be. The 4 times 2x is 8x times x squared minus 5 to the third. And I'm not going to distribute it out because it is in no way helpful for me to do that. And now let's consider the next one. Okay, f of x is the square root of 4x minus 3. So I am square rooting, but the thing I'm square rooting is the 4x minus 3, which also has an interesting derivative. Okay, so I'm going to do the outer derivative first. The outer derivative is that this is a square root function. So since its square root is to the 1/2, so I'm going to bring down the 1/2. I don't mess with whatever's in the parentheses, but I am going to lower it to the negative 1/2. And then the chain rule says I need to take the derivative of whatever's in the parentheses, which is 4x minus 3, so I'm going to times by 4. And then I'm just going to make this look a little bit nicer. So the 1/2 and 4, 1/2 of 4 is 2. And then since it's 4x minus 3 to the negative 1/2, the negative is going to move it to the bottom. The 1/2 is going to rewrite it as a square root. And then this is just a simplified answer for my first step. Let's try a couple more. Okay, h of x, I'm doing the sine of 5x. I know the derivative of sine, but I am also sining 5x, which is going to mean that now I have to use the chain rule because the thing I am doing the function to has a derivative that's not 1. Okay, the derivative of sine is cosine. Don't mess with the parentheses. Okay, now I'm going to multiply it by the derivative of the parentheses. Derivative of 5x is 5. Okay, and then I'm just going to make it look a little bit better. It's weird to have your 5 on the right because it looks like it might be part of the 5x argument. So h prime of x equals 5 cosine 5x. Okay, for dy equals, so derivative, it could be dy dx or y prime. Okay, I'm doing the ln of x cubed, so I can take the derivative of ln, but then I'm doing it to the x cubed, so I have to also take the derivative of x cubed. Okay, so derivative of ln is 1 over the parentheses. The derivative of x to the third is 3x squared. Okay, so if I simplify this, what do I have? 1 times 3 is 3. If I canceled out x squared, I'm left with an x at the bottom. So dy dx is 3 over x. Okay, should I show you okay, I'm going to show you another method, because if you know log properties, you could have also rewritten this. If I rewrote this, this could also be 3 times ln x because of the power rule where you bring down the log power rule. And then if I did the derivative here, it would just be 3 times 1 over x, which would be 3 over x, and I would get the same answer. So if you notice that log properties are useful, you could just do log properties. Okay, one more. This is going to have the chain rule, but it's going to have like the chain rule chained. Okay, f prime of t, and this should be a t if this is going to be a t. That's a typo. Okay, I'm going to start with the e. The derivative of e to the something is e to the something. Okay, now let's take the derivative of the something. What's the derivative of cosine? Derivative of cosine is negative sine. But I'm doing the negative sine of 3t. Now, there's still parentheses. What's the derivative of 3t? Now I need to times it by 3. So I had to keep going until I did the derivative of e to the something, and I did the derivative of the cosine, and then I went in and did the derivative of the 3, and it's kind of like a chain reaction. It keeps going. Okay, let's just make it look a little bit better. What do I want to do? I'm going to move the negative and the 3 to the front. I think I'm going to move the sign to the front too, and let's keep the exponent at the end. Okay, so f prime of t equals negative 3 sine of 3t times e to the cosine of 3t. Okay, let's do chain rule again, but this time we're going to use a table to evaluate chain rule. Okay, so A says f of x equals the quantity g of x squared, and they gave me a table with various values. So let's find the derivative, and I'm not going to worry about the 4 yet. Okay, so this says take g of x and then square it. So I'm going to take this thing and square it. So first, let me do the derivative of the squared part. The squared says bring down the 2 and lower it a degree. Okay, so 2 g of x to the first power, so I don't need to write the first power. And then the chain rule says I need to times it by the inner function's derivative, so times g prime of x. Okay, now it says find f prime of 4, so let's go ahead and plug in 4. But don't skip to the second step. Please show the first step. 2 times g of 4, what's g of 4? G of 4 is 3 times g prime of 4, negative 2. So f prime of 4 is negative 12. Let's try the next one. B, f of x equals h of g of x. So this is h being applied to g. So g is my inner function. Let's do it in terms of f prime of x. So I'm going to do the derivative of h prime. Don't mess with the parentheses yet. Okay, chain. Since I'm doing h prime of g of x, I'm going to multiply by the derivative of g of x, which is g prime of x. Okay, now let's go ahead and plug in 4. H prime of 4. So I want h prime of g of 4. What's g of 4? G of 4 is 3 times g prime of 4, which is negative 2. Okay, now what's h prime of 3? H prime of 3 is negative 3. So this is going to be negative 3 times negative 2, so 6.